Hello, everyone. Today, if you read the top of the screen, you're going to see what we're going to be doing today. Today, we're talking all about something called a z-value. Now, for today, mostly we're focusing on the how to use the formula. Tomorrow we're actually going to get into like why we need this, what does it actually mean. But today, we're just looking at how do we use the formula. Now, the calculation for a z-value, like I said, don't need to know what it is particularly, but you do need to know what each of the pieces stand for. So if you look in our formula right here, each one of these pieces obviously is going to stand for something pretty specific. We obviously have our z-value right here. That's going to represent something, and we're going to use that value tomorrow. But whatever the other variables are, this x is whatever the data point is that we're looking at. This guy right here, this guy is always representing our mean. So whatever the middle of the the middle of the normally distributed graph is, that value would go there. And then the number on the end, this guy is our standard deviation. All right. Now we can use this formula in a lot of different ways. Whoa. We can use it in a lot of different ways. Most of the time, kind of like I mentioned, usually we use it to find the z-value, but that doesn't mean we can't use it to solve for any of the values in the formula. So the first one that we're going to look at is, it says find z if x equals 28.3, u equals 24.6, and theta equals 1.63. Excuse me, sigma is 1.63. It says indicate the position of x in the distribution. So obviously this one, if we plug in everything in their respective locations, if this one is asking me to find z. So I'm going to plug in 28.3 for x. I'm going to plug in 24.6 for my mean, and then I'm going to plug in 1.63 for my standard deviation. And honestly, if you type all of this into your calculator, it's going to give us z equals 2.30. Now, especially, this is more of a note for whenever we find z values, we always round z to 2 decimal places. And this is going to play a factor into something that we do tomorrow, but especially, it's really only z. All the other ones, and this goes for pretty much everything though, in that we're going to round everything to 2 decimal places, but you just want to be super careful whenever we round z, because how you round z is going to affect your final answer tomorrow. So we always want to round to 2 decimal places. So we get 2.30. And all that really means is whatever our normally distributed set looked like, since our mean was at 24.6, the z value basically is telling us that because it's positive, it just means that our data point 28.3 is falling to the right of the mean. If it was negative, then that would tell us that our z value is falling to the left of the mean. And the 2.3 kind of represents how far away it's going to be. But overall, that would be our z value. Now, like I said, though, we can use that formula to solve for any of the variables that are in there. So if we look at part B, it says find sigma or find our standard deviation if our data point is at 28.3, our mean is 24.6, and our z value is 0.63. So obviously I'm going to plug everything in their respective locations. The z value goes on the left side. My data point x is going to go 28.3. I'm going to subtract the mean, and I'm going to divide by whatever our standard deviation is, which in this problem we don't know. Now, how we solve, usually I always go about simplifying things if there's something we can simplify. And here I can simplify everything that's on the numerator right here. If I simplify and do 28.3 minus 24.6, that's going to give us 3.7. And now all we have to do is solve for sigma. Now, anytime we have fractions, we always kind of want to keep in the back of our minds that cross multiplying is always something that works when we're going to solve for fractions, especially in this problem, like when we have variables on the denominator of the fraction. So remember, cross multiplying, we multiply one numerator by the opposite side of the equation's denominator. So that's going to give me 3.7, because times 1 is just 3.7. And then on the other side, I'm going to take 0.63 times my standard deviation. And now I can solve pretty easily. I'm going to divide both sides by 0.63, and that's going to tell me my standard deviation is going to be 5.87. Okay. Now, part C is pretty much the same process. There is one small catch that we just want to be really careful of when solving for our mean. So nothing about how we plug this in is any different than the one before. Plug in our Z value. Our data point is 119.87. I don't know my mean in this case, so that I'm going to leave. And my standard deviation is 14.9. So again, plug everything in their location. We can't really simplify as much like we did in the previous problem, but that doesn't mean that just means we're going to go immediately to our cross multiplying. So if I take negative 1.45, I'll multiply it by 14.9, that's going to give me negative 21.61. Multiplying the other sides, if I take 1 times the entire numerator here, we're just left with 119.87 minus our mean. Now, when we solve, hopefully you're thinking to yourself, well, I need to get my mean alone on one side. So we're going to subtract 119.87 over to the right hand or to the left hand side. And that's going to leave me with negative 141.48 equals. Now, this is where we have to be careful because right now we're technically subtracting our mean. So we just have to be careful because we want to completely solve. So I'm going to divide both sides by -1 to get my mean to be positive. And that's going to give me my final answer of 141.48. Okay. So just be really careful when you're cross multiplying. Make sure you've solved completely. But at the end of the day, that is how we use our formula. All right. So you guys can now move on and you guys can start the homework for the day.